Hello all and welcome to another session on the topic of file organization for the subject of operating systems. In today's session we will be discussing about free space management and file access control. Now free space is a space which is not occupied by file. So free space management plays a very important role. Now as the files grow and shrink, the file system maintains a record of the location of blocks that are available to store new data, which is called free blocks. As the file system may use a free list to keep the track of free space, which has been shown in this figure. Now you can see that there is a diagram in which a secondary storage is shown. The shaded section shows the occupied blocks and the white section shows the free blocks. Now the free list is a linked list of blocks with the locations of the free blocks. So the last entry of a free list blocks stores the pointer to the next free list block. If the last entry of the last free list block stores the null pointer, it indicates that there are no further free list blocks. When the system needs to allocate new block to a file, it finds the address of a free block from the free list. System writes the new data to the free block and removes the block's entry from the free list. The file system allocates block from the beginning of the free list and appends the freed blocks to the end of the list. The pointers to the head and tail of the free list can be stored in the file system's superblock. So these techniques require a little bit of overhead in order to perform free list maintenance operations. The storage device's free space become fragmented due to free blocks allocation, and the adjacent entries in the free list will point to the non-contiguous blocks now. As a result, the sequential file data will be allocated in the non-contiguous blocks, which generally increase the access time. Alternatively, the file system attempts to allocate contiguous block by searching or sorting the free list. This also causes an overhead. Now another common method for free space management is bitmap. Now you can see on the screen a bitmap contains one bit for each block in the file system, where the ith bit corresponds to the ith block in the file system. So in implementation, a bit in a bitmap is 1 when the corresponding block is in 0 and it is in use, and 0 when it is not. I repeat again, in implementation a bit in the bitmap is 1 when the corresponding block is in use, and it is set to 0 when it is not in use. Means 0 means it is free. So bitmap generally spans multiple blocks. One of the primary advantage to bitmaps over free list is that file system can quickly determine if contiguous blocks are available at certain locations on the secondary storage. The disadvantage to bitmap is that file system may need to search entire bitmap in order to find a free block, which results in execution overhead. So in many cases, this execution overhead can be ignored because the processor speed is much faster in today's system. So this finishes the free space management. Next comes the file access control. Now, files are often used to store sensitive data such as credit card numbers, passwords, security numbers, etc. etc. So, file system should include some mechanism to control user access to data. So, one file access technique is to control access to create a two-dimensional access control matrix. Let me show you. Now, this matrix lists all the user and all the files in the system. The entry aij is 1 if the user I is allowed to access the file j, otherwise the entry aij is set to 0. For example, in the figure, the user 5 can access all the 10 files and user 4 can access only file 1. So now in an installation with a large number of users and a large number of files, this matrix would be quite large also. So allowing one user can be quite large, and also allowing one user to access another user's file is most important of the times, is mostly very rare. So matrix would be extremely sparse also. Now since user are very much, so matrix is large. Now one user can allow other user to access its file. It is a very rare thing. So the matrix will also be extremely sparse. Sparse means it will be having many zeros in it. So in order to make the matrix concept useful, it would be necessary to use codes to indicate various kinds of access, such as read only file, write only file, execute only file, read write, etc., etc. So this technique could lead to increase the size in the matrix as the number of entries increases. Now we can also implement access control by using user classes. So this technique requires considerably less space in order to control the access to various user classes. Now a common file access classification scheme is dividing the access based on the user's type. For example, owner. Here owner is the user who created the file. So the owner has unrestricted access to the file and can also change the file permissions. Next comes specified user. It is another individual which may use the file which the owner specifies. Next comes the group. The users are often members of a group working on a particular project. Now in this case, the various members of the group may all be granted access to each other's project related file. Next comes the public. Most of the system allow file to be designated as public, so that it may be accessed by any number of systems under community. So by default, public access rights typically allow users to read and execute files, but it cannot write in it. So this access control data is stored as a part of the file control block, and it also consumes a very less amount of space. So access control topic and free space management topic is over for this session. Thank you very much for being part of this session.